Okay, Bismillahirrahmanirrahim. We start our lecture today by chapter 4. Chapter 4 is formal logic, quantifier, predicates, and validity. Okay, as you can see before this, we are also for chapter 3, we have looked VDM, and then we have also looked for Z notation. Z notation. Okay, and then for this one, we look for formal logic, quantifier, predicate, and validity. Okay, normally when you talk about the formal logic, okay, formal logic is abstract of study, basically for the proposition, segment, or assertively used sentences, and also deductive argument. Okay, okay, this one, okay, for the formal logic. Okay, only basically is for study of proposition, statement, or use sentences and deductive argument. Okay. Yeah, what is example? Example of formal logic is the use of syllogism to explain connection, those connection for proposition, statement, use sentences, and deductive argument. Okay, and then okay, for this lecture, we go for the variable and statement, quantifiers, okay, and then predicates, truth of the expression, unary, binary, and then we go until n-ary predicates, and then interpretation, scope of a variable in expression, translation of verbal statement, and negation of the statement. This one is just an overview because last time in the subject of discrete mathematics, you have learned a lot. Okay, what is a variable? Variable is a symbol that stand for individual in the collection or set. For example, you have a variable x may stand for one of the days, and then we may let x be Monday, x also be Tuesday, and etc. Okay. Basically, the variable is the predicate is quantified by the quantifier. Okay. Variable normally predicate quantified quantifier. Okay, we normally use the letters at the end of the alphabet as a variable such as x, y, and z. And then a collection of objects is called a domain of object, or we call it as a domain of discourse. The 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 main domain of the object. For above example, the days in the week is the domain of the variable x. Okay, we have x as Monday. Okay, x also for the Tuesday, for Wednesday. Okay, and we can call it x collection of object. It's a domain of object. Basically, here is domain of x. Okay, do you have any questions so far? Is it okay? Boleh ke? Okay, and then statement. Statement is a declarative sentence that having a truth value. Is a statement. Declarative sentence having truth value. Okay, for example, for the statement. Okay, example of statement. Okay, today is Thursday. Today I have formal method class. Okay. Then uh, okay, for each of the sentences that listed here, one, two, three. Okay, this one is not a sentence. This one. Why? Kenapa? Okay, because this one is a question. Question and comment are not a statement. Okay, this one I think just a revision. Question and comment. Okay, are not a statement. Okay. Okay, for this one, you should be able to decide whether the statement is either true or false, because it have a truth value. Okay, and then symbol for statement, it is conventional to use a lowercase such as Q, P, Q, R, S to represent logic statement. For example, okay, we have P. Today is uh, today is Saturday. Okay, and then we have Q. Today I have math class. Okay, this one is referring to lowercase. On here, lowercase. Okay. Okay, in discussion, in the discussion of logic, when we encounter a subjective or value laden term, an opinion, such as dishonest, we will assume that the discussion in that term has precisely defined. Okay, and then we have quantifiers. Quantifiers is the statement that containing more or more of this word is quantified statement. Okay, we quantified something. Okay, for here in formal logic, for the quantifier, we are defining or we are quantifying the domain of the discourse, or okay, the domain of discourse. Okay, and then proportional WFF is a well-formed formula, have rather limited expressive power. For example, for every x, okay, we have x is greater than zero. Okay, this one in a well-formed formula. Okay, it is a finite sequence of symbol. Okay, what is a well-formed formula? Is a finite. Finite mean it can be quantified. Is a finite sequence of symbol from a given alphabet that is part of formal languages. Okay, this this simply we can call it as a formula by a finite sequence. Okay, for example, we have here, okay, for every x, x is greater than zero. And then quantifiers are phrases that are referring to the quantities, such as for some or for all, for every, indicating how many objects that have a certain properties. Okay, this one referring to the domain. Okay, two kind of quantifiers here. The first one is we can call it as a universal quantifier that represented by reverse A. We can call it as a for all, for every, for each, for any. And then for the universe existential quantifiers represented by reverse E is for some there exists. Okay, this one is not all. Okay, and then for the last, for at least one, also we can call it as existential quantifier. Okay, in logic, quantifier is a language element that help in generation or quantification, which is construct that the number of specimen in given domain, domain of discourse. Okay, for example, yeah, I give you another example. Okay, for instance, the universal quantifier E. Okay, um, in the first order formula, we have Px that express that everything in the domain satisfied in the property denoted by P. This one is satisfy the properties. On other hand, we can use the existential quantifier. Okay, expresses that there is something in the domain that which satisfy the property P. A formula where a quantifier takes a wider scope is called a quantified formula. The quantified formula must contain a bound variable and subformula that specifying a property of the reference of that object. Okay, later we see the negation of the properties. Okay, this one is in detail. We have first we have universal quantification. Okay, this one is Px is the for all value of x in the domain, and then for all is a universal quantifier. For example, we have symbol e. Okay, for all x is a member of D. D is domain of predicate variable. Is true if and only if IFF. Px is true for every x in D. Please remember P is a domain that satisfy the property. Okay, how to satisfy the property need to have some some expression some expression that quantify take the wider scope, or we can call it as a formula, okay, like this. Okay, same goes to existential quantifier. Is quantifier something that tells the amount of or a quantity. For example, we have a symbol e. For some, x is a member of D, whereby the px is true if and only if px is true for at least one x in D. Okay, for example, some birds are angry. This one is an example. Okay, so far, do you have any question? Is it okay? Okay, another example. I give you another example. Okay, for example, here, all dogs are poodle. Okay, this one statement we can call it as false, because we know that there is at least one dog that is not a poodle. Okay, number two, we have some books have hardcover. Okay, for this one is true. Okay, because we know that there is at least one book that doesn't have a hardcover. Okay, another example. No United States president were resident of Georgia. Okay, this one is false, because we know that there was at least one president who was from Georgia. Okay. Okay, this one another example. Existential quantification is quantifying meaning that it exists, or we can call it as there is at least one, or for some we can use the following symbol. This one is existential. Here is a formal way to say when some values of predicate variable x can take in domain D. Please be remember domain D is a domain of discourse. Okay, and then the predicate is true for some x belonging to D, whereby D is a member of the predicate. Okay, for example, D is a bird. Px is a x is angry. Okay, and then for some birds, P are angry. The term nested quantification refers to the statement that involving several quantifiers. Okay, we have several quantifiers that we can mix together. Okay, so far do you have any question? Okay, yeah. Let me give you another example. Okay. Okay, please be remember for the predicate. Predicate is a portion of a statement. Must be statement. That is mention about the subject or domain. In logic, the predicate can be represented through use of predicate symbol. We can use the predicate symbol. Or sometimes we can use the predicate variables. Okay, for example, we have Mary is studying for a bachelor degree at UPSI. Okay, this one is example. Okay, let P be predicate symbol for is studying for bachelor degree at UPSI, and let X be the predicate variable, which take the value from the set of all students. Then the above sentence is represented symbolically as X is studying for a bachelor degree at UPSI or PX. Okay, we can represent as a PX. Okay, and then let's y be also be predicate and takes the value of from the all colleges, and R stand is studying for a bachelor degree. The above sentence can be represented as X studying for a bachelor at Y, or we can call it as R X Y. Okay, the predicate is sentence containing a specific number of variables and become a statement when specific variables are substituted in place of the predicate variable. The value are taken from the domain of the predicate or domain of discourse, which is the main focus of the predicate variable. And the domain X is the set of all students, and the domain Y is set of colleges. Okay, we have domain X and domain Y. Okay, X is a set of all students. Okay, and then we have Y, it's a set of all. Okay, okay, and then exercise of universal and existential. This one, please do in a Padlet. Okay, and then predicate. Okay, okay, it is a verbal statement which describe the property of variable, usually represented by the letter of P, and then we can use the notation Px is being used to represent some unspecified property or predicate that X may have. It belong to the predicate. For example, we have Px, X has 30 days. When you replace the uh, specific domain, for example, here in month, month April, April has 30 days, which is the truth value of for all x Px, where x is all the months and Px equal to x has less than 32 days, because in month we have okay, greater than 0 and then less than 32 days. Okay, and then combining the quantifier, this one also we can call it as a nested. Okay, we have form for all x Px or for some x Px. And then the collection of object is called the domain of interpretation and must be contain at least one object. Okay, because it is object, it must have some instantiation. Some instantiation. Okay, specific value, collection variable text. Okay, okay, and then okay, truth value of the expression. Okay, this one also you can you can do this exercise and upload to Padlet. Okay, and then this one is combination unary, binary, and n-ary predicates. Okay, a predicate that involve the property of single variable is called unary predicates. Binary, ternary, and n-ary predicates are also possible. Okay, and then the negation. Okay, negation is you negate to understand the negation of universal conditional statement. Okay, you can review if then conditional negation and negation of for all statement. If then you can use if then. Okay, this one logically same, equivalent. This one also logically equivalent to this one. Okay, okay, for the interpretation is a formal definition that consists the following expression. First one is collection of object called domain of interpretation. Assignment of property of the object in the domain to each predicate in the expression, and then assignment of the particular object in the domain is constant symbol in the expression. Okay, and then predicate well-formed formula can be similar to propositional well-formed formula using a logical connective, which predicate and quantifier, okay, combine. Okay, and then must be obey the rule of syntax to be considered as a well-formed formula. For example, we have for all Px okay, implies Qx. This one is a well-formed formulas. And then the scope of variables. Okay, we have a scope of variable by using parentheses or bracket. Okay. And then translation of verbal statement to symbolic form using intermediate statement. Okay, this one you can combine. Every person is nice can be replaced as for anything. If it is a person, then it is nice. Okay, this one is convert to English. Okay, so almost always for some goes with the conjunction, and E for all goes with the implication. Please be remembered. Okay, when you go by the well-formed formulas, okay, it it must goes with the implication with for all, and then for the conjunction it must go for some for WFF. Okay, this one is more translation. You can refer upon. Okay, this one negation. The example. Okay, exercise. You can refer this one. Okay, for the validity is analog of tautology of propositional logic. What is tautology? Tautology is the propositional formula that is true under any possible Boolean valuation of its propositional variable. Okay, this one tautology. Valuation of it. Okay. Okay, and then there's an analog to the truth predicament in a propositional logic. Some tautology of predicate logic are analog. Okay, some of the tautology are propositional logic. Some of them are not, depending on the truth value, depending on the intrinsic truth and methodology. Okay, and then this one is a validity example. Okay, okay. Please be remember. Okay, when you talk about for all, we go by the yeah, and then we go by this junction. Okay, it's not valid since the property cannot be valid for all objects. Okay, how about this one? Invalid because can prove by mathematical concept by taking Px is x is not even, and Qx whereby x is odd. In that case, the hypothesis is true, but not the conclusion. Is false because it is not the case that every integer or is even or every integer is odd. Okay. Okay, and then class exercise. Please do it also in the Padlet. Okay. Any question? Do you have any questions so far? Is it okay? Okay, because okay.